Hello viewers, welcome to my channel Online Biology Tutorials. In today's live, we will be reading the chapter 9 Friction from class 8 Science NCERT that is used in the CBSE board. In case you are interested in hearing the audio of first 8 chapters, they are already being uploaded in the playlist of Audiobook Class 8 Science. Whenever you will be hearing the audio of this chapter, requesting to please share it with your friends for the maximum reach. I hope the screen is visible and it is clear too. So let's begin with the reading of chapter 9 Friction, Class 8 Science NCERT. Slip when we step on a banana peel as seen in figure 9.1. Why is it difficult to walk on a smooth and wet floor? Figure 9.1, a boy falls down when he steps on a banana peel. You will find the answers to such questions in this chapter. 9.1 Force of friction. Activity 9.1. Gently push a book on a table as seen in figure 9.2a. You observe that it stops after moving for some time, for some distance. Repeat this activity pushing the book from the opposite direction as seen in figure 9.2b. Does the book stop this time too? Can you think of an explanation? Can we say that a force must be acting on the book opposing its motion? The force is called the force of friction. Moving on to next page. You saw that if you apply the force along the left, friction acts along the right. If you apply the force along the right, the friction acts along the left direction. In both cases, the forces opposes the motion of the book. The force of friction always opposes the applied force. In the above activity, the force of friction acts between the surface of the book and the surface of the table. Is the friction the same of all the surfaces? Does it depend on the smoothness of the surfaces? Let us find out. 9.2 Factors affecting friction. Activity 9.2. Tie a string along a brick. Pull the brick by a spring balance. You need to apply some force. Note down the reading on the spring balance when the brick just begins to move. It gives you a measure of the force of friction between the surface of the brick and the floor. Now, wrap a piece of polythene around the brick and repeat the activity. Do you observe any difference in the readings of the spring balance in the above two cases? What might be the reason for this difference? Repeat this activity by wrapping a piece of jute bag around the brick. What do you observe? Spring balance is a device used for measuring the force acting on an object. It consists of a coiled spring which gets stretched when a force is applied to it. Stretching of the spring is measured by a pointer moving on a graduated scale. The reading on the scale gives the magnitude of the force. Activity 9.3. Make an inclined path plane on a smooth floor or on a table. You may use wooden board supported by bricks or books. Put a mark with a pen at any point A on the inclined plane. Now let a pencil cell move down from its point. How far does it move on the table before coming to rest? Note down the distance. Now spread a piece of cloth. Next page. I hope the screen is visible and clear. Over the table, make sure that there are no wrinkles in the cloth. Try the activity again. So in figure 9.4, the pencil cell covers different distances on different surfaces. Repeat this activity by spreading a thin layer of sand over the table. Maintain the same slope throughout the activity. In which case is the distance covered the minimum? Why is the distance covered by the pencil cell different every time? Try to reason why. Discuss the result. Does the distance covered depend on the nature of the surface on which the cell moves? Could the smoothness of the surface of the cell also affect the distance traveled by it? I shall try the activity by wrapping a piece of sandpaper around the cell. Friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them, as seen in figure 9.5, this one. Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surfaces, there are a larger number of irregularities, so the force of friction is greater if a rough surface is involved. Next page. We see that the friction is caused by the interlocking of irregularities in the two surfaces. It is obvious that the force of friction will increase if the two surfaces are pressed harder. You can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. Figure 9.6, you have to push on the box to keep it moving. Recall your experience when last time you moved a heavy box from one place to another as seen in figure 9.6. If you have no such experience, get that experience now. What is easier, to move the box from rest or to move it when it is already in motion? The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. On the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. When the box starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So the sliding friction is slightly smaller than the static friction, and you find it somewhat easier to move the box already in motion than to get it started. Let's move to this side now. 9.3, friction, a necessary evil. Recall now some of your experiences. Is it easier to hold a cooler or earthen pot or a glass tumbler? Suppose the outer surface of the tumbler is greasy or has a thin layer of cooking oil on it. Would it become easier or more difficult to hold it? Just think. Would it be possible to hold the glass at all if there is no friction? Recall also how difficult it is to move on a wet, muddy track or wet marble floor. Can you imagine being able to walk at all if there were no friction? You could not write with pen or pencil if there were no friction. When your teacher is writing with chalk on the blackboard, its rough and surface rubs off some chalk particles which stick the blackboard. Could it happen if there were no friction between the chalk and the board? If an object started moving, it would never stop if there were no friction. Had there been no friction between the tires of the automobiles and the road, they could not be started or stopped or turned to change the direction of the motion. You could not fix a nail on the wall as seen in figure 9.7 or tie a knot. Without friction, no building could be constructed. Figure 9.8 is showing you the soles of shoes wear out due to friction. Next paragraph. On the other hand, friction is an evil too. It wears out the materials, whether they are screws, ball bearings, or soles of the shoes, as seen in figure 9.8. You must have seen worn out steps of foot over bridges at the railway stations. Friction can also produce heat. Vigorously rub your palms together for a few minutes, as seen in figure 9.9. How do you feel? When you strike a matchstick against the rough surface, it catches fire, as seen in figure 9.10. You might have observed that the jar of a mixer becomes hot when it is run for a few minutes. You can cite various other examples in which friction produces heat. In fact, when a machine is operated, heat generated causes much wastage of energy. We shall discuss the ways of minimizing friction in the following section. Next page. Yes. 9.4 Increasing and reducing friction. As you have seen in the previous section, friction is desirable in some situations. Have you ever thought why the sole of your shoe is grooved? It is done to provide the shoes better grip on the floor so that you can move easily and safely. Similarly, the treaded tires of cars, trucks, and bulldozers provide better grip with the ground. Same thing, whichever has been spoken here, the images are being given here for the shoes and for the tires. We deliberately increase friction by using brake pads in the brake system of bicycles and automobiles. When you are riding a bicycle, the brake pads do not touch the wheels. But when you press the brake lever, these pads arrest the motion of the rim due to friction. The wheel stops moving. You might have seen that kabaddi players rub their hands with the soil for a better grip of their opponents. Gymnasts apply some coarse substance on their hands to increase the friction for the better grip. In some situations, however, friction is undesirable and we would want to minimize it. Why do you sprinkle fine powder on the carom board? You might have noticed that when a few drops of oil are poured on the hinges of the door moves smoothly. A bicycle and a motor mechanic uses grease between the moving parts of these machines. In all the above cases, we want to reduce friction in order to increase efficiency. When oil, grease, or graphite is applied between the moving part of a machine, a thin layer is formed there and moving surfaces do not directly rub against each other, as seen in figure 9.13. Interlocking of irregularities is avoided to a great extent. Movement becomes smooth. The substances which reduce friction are called lubricants. In some machines, it may not be advisable to use oil as lubricant. An air cushion between the moving parts is used to reduce the friction. Next page. Can we reduce friction to zero by polishing surfaces or using large amount of lubricants? Friction can never be entirely eliminated. No surface is perfectly smooth. Some irregularities are always there. 9.5 Wheels reduce friction. You must have seen attaches and other pieces of luggage fitted with rollers. Even a child can pull such pieces of luggage, as seen in figure 9.14. Why is it so? Let us find out. Activity 9.4. Take a few pencils which are cylindrical in shape, place them parallel to each other on the table. Place a thick book over it as seen in figure 9.15. Now push the book. You observe the pencils rolling as the book moves. Do you feel it is easier to move the book in this way than to slide it? Do you think that resistance to the motion of the book has been reduced? Have you seen heavy machinery being moved by placing logs under it? When one body rolls over the surface of another body, the resistance to its motion is called rolling friction. Rolling reduces friction. It is always easier to roll than to slide a body over another. That is the reason it is convenient to pull luggage fitted with rollers. Can you now understand why the wheel is said to be one of the greatest inventions of the mankind? Since the rolling friction is smaller than the sliding friction, sliding is replaced in most machines by rolling by the use of ball bearings. Common examples are the use of ball bearings between hubs and axles of ceiling fans and bicycles as shown in figure 9.16. Students, in case you are liking the audio, do hit the like button. And in case you are interested in hearing the audio of first 8 chapters of class 8, they are already being uploaded in the playlist. 9.6 Fluid friction. You know that air is very light and thin, yet it exerts frictional force on objects moving through it. Similarly, water and other liquids exert force of friction when objects move through them. In science, the common name of gases and liquids is fluid. So we can say that fluids exert force of friction on objects in motion through them. The frictional force exerted by fluids is also called drag. The frictional force on an object in a fluid depends on its speed with respect to the fluid. The frictional force also depends on the shape of the object and the nature of the fluid. It is obvious that when objects move through fluids, they have to overcome friction acting on them. In this process, they lose energy. Efforts are therefore made to minimize friction. So, objects are given special shapes. Where do you think scientists get hints from these special shapes? From nature, of course. Birds and fishes have to move about in fluids all the time. Their bodies must have evolved to shapes which would make them lose less energy in overcoming friction. Look carefully at the shape of an aeroplane. Do you find any similarity in its shape and that of a bird? In fact, all vehicles are designed to have shapes which reduce fluid friction. So, this friction chapter 9 of class 8 was a short chapter. We are done with its reading. So, the keywords that were there in the red part are ball bearing, drag, fluid friction, friction, interlocking lubricants, rolling friction, sliding friction, static friction. Before we end up this audio, let's start the summary. Friction opposes the relative motion between two surfaces in contact. It acts on both the surfaces. Friction depends on the nature of surfaces in contact. For a given pair of surfaces, friction depends upon the state of smoothness for those surfaces. Friction depends on how hard the two surfaces press together. Static friction comes into play when we try to move an object at rest. Sliding friction comes into play when an object is sliding over another. Sliding friction is smaller than static friction. Friction is important for many of our activities. Friction can be increased by making a surface area rough. The sole of it is surface rough, not surface area. The sole of the shoes and the tires of the vehicle are treaded to increase friction. Friction is sometimes undesirable. Friction can be reduced by using lubricants. When one body rolls over another body, rolling friction comes into play. Rolling friction is smaller than sliding friction. In many machines, friction is reduced by using ball bearings. Fluid friction can be minimized by giving suitable shapes to bodies moving in fluids. So, the riddle that is given to you at the end of this page is: in some situations, I oppose the motion. In other situations, I facilitate the motion, but I always oppose the relative motion. Between two moving surfaces, put some lubricant and I become small there. Make the moving surfaces rough. I make the movement tough. I may be static, sliding, or rolling, but whenever two surfaces are in motion, I am always there. Tell me who I am. So you need to find the answer of it and you can write it in the chat right now. We are done with the live reading of chapter 9 friction class 8 science NCRT used in CBSE board. Please consider subscribing so that you can get the recent notifications whenever the next audio will come. Stay connected. Thank you.